Welcome to Turbo Thumb Assembly video. I am Ali Sadat. I will be your guide through the assembly process step by step, and together we will bring your controller to life. Without further ado, let's begin.
To access the build instructions, navigate to the Turbo Thumb page. You can find the complete assembly instructions here on Sadat Akhavi Academy website. These are the list of recommended tools to build this kit. After the overview section, you can find the kit's inventory. Here is the 3D printing section. Printing parameters like infill, quality, and filament types are suggested here as well. Feel free to change the color to what you prefer. If you are using a service provider to print your parts, there is a document could be found here called 3D Printing Asset Sheet. This file only includes the details the service provider needs to print the files for you. Click on the link and download the project files. Extract them and put them on your build plate as suggested here. Then slice them and print. We need to upload the code of microcontroller before starting building the kit. As a part of this process, we need to install the chipset driver, Arduino IDE, and its related libraries. Let's start by connecting the microcontroller. Navigate to your device manager, and you will see the connected board here if you already have the drivers installed. If you don't have the required driver installed, the microcontroller will show up under other devices, like this. To install the needed driver, click on the link provided, or simply copy the link from the document and paste it to your browser. Download the file for your operating system and follow the process of the installer. After this, you should be able to see your microcontroller board displayed on the ports. Your COM port might be different than mine, which is totally fine.
In this section, we are installing VS Code and the Platform IO extension. Platform IO is a common IDE used to program microcontrollers. Navigate to the VS Code download page and download the proper version of VS Code for your operating system. Start the installation process and follow the recommended steps. In VS Code, click on the extension icon. Then search for Platform IO and click on Install. Here, we move to downloading the project's code and applying the proper changes. To download the code, visit the project's web page and click on Software Firmware link. Download the code as a zip file and extract it. Open Platform IO IDE, navigate to the project folder. To configure Platform I/O to communicate with the microcontroller, navigate to Devices in the IDE. Make sure the microcontroller is connected to your PC and click on Refresh. Copy the port number and name. Paste the port number and name for upload and monitor ports in the platform.ini file. Platform I/O uses these to send the compile code and receive the monitoring logs. Navigate to the setting and struct.hpp file to configure the data communication channel of your turbo thumb controller. If you have multiple turbo thumb controller, you can set them to different data channels to avoid interference between them. If you have just one controller, you can leave this to the default setting. As you can see here, these two controllers don't interfere with each other since they are placed on different data channels. Now we are ready to upload the code to the microcontroller. Click on the upload button, which is a button with an arrow icon at the bottom bar of VS Code. To check if the microcontroller is programmed correctly, click on the serial port monitoring button, which is a button with a power plug icon. You should be able to see some incoming logs from the microcontroller.
We start the electronic part assembly process by connecting wires to the microcontroller board using this table. These are left and right keyboard wires, and we are securing them in place using hot glue after connecting them. Then we move to connecting left and right joystick wires. These are the left and right wires we are connecting, and we secure them using hot glue. These are power connectors we are connecting here. These include incoming power from the batteries, 5-volt output, 3.3 volt output for RF module, and ground connectors. After securing them using hot glue, we move to LCD wires. The last wires we are going to connect are for the radio module, and we secure them using hot glue. Here, we start to integrate the electronics with turbo thumb chassis. Assemble the parts as shown in the document. Note the battery's door hinges have an oval shape on one side, helping with fastening the screws. These are spaces to be used to protect microcontroller board from getting damaged by screws while securing it in place. In this section, we build the power circuit. As illustrated in the diagram, the positive or red wire of 9-volt battery connectors will be connected to the left and right connectors of the power switch, enabling 2 independent power supplies as redundancy. The middle pin of the switch is used to supply the power to the microcontroller board via V-in port. We start by strapping ends of the brown wire, which will be used as a shared wire between the 2 negative or ground connectors of the batteries. After soldering the negative wires, use heat shrink tubing to isolate the connection. Heat shrink tubing is a type of plastic that shrinks when heated, and it is commonly used for connection isolation. Next, solder the positive or red wires to the left and right connectors of the switch. Be careful not to overheat these connectors, as they can transmit heat and melt the switch, as shown here. To connect V-in from the microcontroller board to the middle connector of the power switch, first install the middle panel. Pass the V-in wire through the switch mount, strip it, and solder it to the middle connector. Once this is done, you can pass the battery connectors and put them into the battery pockets. Finally, mount the switch into its place. We use 2 springs as our distribution points for 5-volt power and ground to the other modules. These springs are mounted to the board using 2 screws. After identifying the 5-volt and ground wires, cut and prepare 6 more wires with female connectors. Connect 3 of these wires that you prepared and the 5-volt wire coming from the board to one of the springs. Then mount it to the chassis using a screw. Follow the same process for the ground wire. The power circuit flow works as follows. The microcontroller board receives power directly from the power switch, and it converts it to 5-volt using a voltage regulator on board. The other modules that require 5-volt, like joysticks and the LCD, can access 5-volt power via the distribution points. Now we have a 5-volt distribution point on the right hand side and ground distribution point on the left hand side. Next, we install the LCD display of the remote controller. This kit's LCD has a 2 rows 16 characters display. The first line is used to display messages, and the second line of the display is for action indicators. The LCD communicates with the microcontroller using I2C protocol. The SCL and SDA pins on the microcontroller board should already have wires connected to them. Follow the diagram and connect the SCL pin of the LCD to SCL pin on the microcontroller and the SDA pin of the LCD to the SDA pin of the microcontroller. Connect the VCC pin of the LCD to one of the 5-volt wires from the distribution spring and the ground pin of the LCD to one of the wires coming from ground distribution spring. Turn on the device to ensure the LCD is powering on. If nothing is visible on the screen, use the potentiometer at the back of the module to adjust the display contrast. Please note, since we don't have the RF module installed yet, the device will show an error message and reboot after a few seconds. Mount the LCD in place using 4 provided 2M screws. In this step, we are going to install the RF module. Please note, this module uses 3.3 volt, not 5 volt. It is a very sensitive module and requires a capacitor to be placed on the power connector to remove any incoming noise via power lines. Identify the 3.3 volt and the ground wires on the microcontroller board. These pins should have already wires connected to them. The provided capacitor is an electrolytic capacitor and has positive and negative legs. In these type of capacitors, the positive leg is usually longer than the negative leg, and there is a marking on the body of the capacitor pointing to the negative leg. Insert the longer leg of the capacitor into 3.3 volt pin and the negative leg, or the shorter one, into ground pin. Then connect the 3.3 volt wire to the VCC pin of the RF module and the ground wire to the ground pin of the RF module. This might be a little bit tricky, just do it patiently. Connect the remaining wires according to the diagram. Now, when you turn on the device, the RF module error should be resolved and the device should stay on. Secure the RF module connectors using a hot glue gun. This controller uses 2 joysticks, each with 5 wires to be connected. Follow the diagram. 2 wires are for X and Y axes, 1 wire is for press button, 1 for 5 volt, and last wire for ground. First, mount the joystick with the provided 2M screws as shown. The 5-volt and ground wires need to be connected to the distribution spring. Then connect the wires as shown in the diagram. Turn on the device. On the screen, you should be able to see arrows following your joystick movement. Pressing the joystick should display an X on the screen. Your controller has 2 keypads, each with 16 press buttons. Connect the wires as shown in the diagram. Place the keypads in their designated positions and close the top panel. The final steps of building your controller are as follows. Close the back panel with screws provided. Place the battery doors. Secure the top panel using screws and connect the hand strap. The Turbo Thumb controller is equipped with 2 internal batteries for redundancy purposes. Additionally, you can use 2 direct ports of the microcontroller board to supply power to the controller. You can mount a power bank at the bottom of the remote controller and secure it using straps extending the operating hours. The controller has 2 keyboards on the left and right hand sides. On the left side keyboard, values on this keyboard are locally significant to the remote controller. They are used to select which remote device the controller selects to control. The selection values are in hex and starting from 0 at the top to F at the bottom. 0 is used to release and deselect any device already selected. F button defined as broadcast mode, in which all devices will respond to the command sent from the controller. Right side keyboard. This keyboard is used to send commands to the remote device, including turn on or off lights, horn, crane, camera movement, or any other accessories your remote device might have. This controller has 2 joysticks on the left and right hand sides. These joysticks are used to control the remote device, and depending on the type of the remote device, they might control the movement direction of the device or other accessories. The Turbo Thumb controller has 2x16 characters LCD display. First line is used to display messages and notifications. Second line displays joystick, keyboard, and health status of the device. 3 digits in the middle of the display are used for RF wireless channel the device is operating on. The remote devices controlled by this remote controller should have the same channel configured to receive the data from the controller. The first character of the second line displays the health status of RF module, and the last character of the second line displays whether the remote controller is actively transmitting data, and the remaining characters of the second line are for joysticks and keyboard's input displays. Here you can see on the left hand side keyboard, when 0 is pressed, no bike is selected. Button 1 has been allocated to the red bike. When 1 is pressed, the red bike is the only device that is responding to the commands. Button 2 has been allocated to the yellow bike. When 2 is pressed, the yellow bike is the only device that responds to the commands. And F is the broadcast mode. When selected, all devices will respond to the commands sent by the controller. When you press the button on the keyboards, the number on the screen should change to a value between 0 and F. The right keyboard input should be momentarily and disappear after a few seconds, while the left keyboard values should remain. This keyboard is your device selector.
Congratulations on completing the kit. I hope you learned something new today and had fun. If you would like to support my work, please like, share, and subscribe to my channel, and join our Discord server and leave a comment. Thank you for watching. Looking forward to seeing you in the next one.